Okay, so this is the first question for the bonus points. So this is the question as reads. An aqueous antifreeze solution is 40% ethanol glycol by mass. The density of the solution is 105 grams over centimeters cubed. Calculate the molarity, and mole fraction of the ethanol or ethylene glycol. So I went ahead and wrote the molar masses here. For the ethylene glycol is 62.07, and the molar mass for water is 18 because it's an aqueous solution. Okay, so we're gonna start by solving for molarity. All right, so let me just write molarity somewhere right here. All right, so we're gonna start with molarity. Oh. Molarity. All right, so in order to solve for molarity, we're gonna need the grams of the solution, which is ethylene glycol, and as we can see, we got 40% solution of ethanol glycol. Okay, so that means out of 100%, there's 40% ethanol glycol. So we can say that there is 40 grams of ethylene glycol. Did I say ethanol? Ethylene. C2H6O2. All right, 40 grams of ethylene glycol. All right, and then we're gonna put that over 100 grams of the solution. 100 grams of solution. All right, and then we're gonna multiply that by the density. Oh, I forgot to mention that is our density. All right, so we're going to multiply that by 1.05 grams over cm3 or centimeters cubed. Then we're going to multiply that times, sorry, there's a little debris. All right, times 1,000 centimeters cubed over liters. All right, and then after that, we're going to multiply by the, oh no, we're not going to multiply. Well, we are going to multiply, but we're going to find moles. So in order to get moles, we're going to need the molar mass. Okay, so the molar mass of, what's it called, ethylene glycol is going to be 62.07. So 62.07 is our molar mass, 62.07 over 1 mole of C2H6O2, and we calculate that, and that should give us our molarity. All right, so we're going to do 40. Oops. Let me just, okay, so it's going to be 40 times 1.05 equals 42 times 1,000 equals 4,200. We're going to divide that by 100 equals 420 divided by 62.07, and we get 6.76. All right, 6.77. All right, let me make sure that's correct again. So it's 40 times 1.05 times 1,000 divided by 100 divided by 62.07. Yep. All right, 66.77. All right. And now we move on to the next little part that we're gonna need. It's gonna be the we just solved for molarity. Now I'm going to solve for molality. All right, so molality. All right, here we go. So for molality, we're going to need the grams of the ethylene glycol again. So that's going to be 40 G of C2H6O2 over the solvent, which is the remaining of the solution, which that's going to be 60 grams, because 100 minus 40 equals 60, right? 100 minus 40. I got to double check because I don't even trust my own math. All right, so 60 grams of solvent. All right, so now we're going to multiply that by 1,000 grams over kilograms. And then we're going to multiply that by the 1 mole of the solution, not the solution, of ethylene glycol of C2H6O2. And we're going to use the molar mass of ethylene glycol again, which is 62.07. All right, and we solve for that. And okay, so we're gonna need okay, so here, so it's gonna be 40 times 1,000. That's all the numbers on top, divided by 60, divided by 62.07, and I get 10.74056.173. So I'm gonna put 10.7. Okay. Oh, and I forgot to put the what you call it, this so this is mole over kilograms. What is this called again? I forgot. And then this is gonna be, what is it, mole over liters. Okay, so mole over liters, mole over liters, mole over kilograms. All right, and then finally we're gonna have to turn the grams of the, oh wait, I'm getting ahead of myself. So now all we need is to find the mole fraction of the ethylene glycol. In order to do that, I'm gonna have to turn the grams of ethylene glycol into moles, and the grams of the solvent, the grams of the solvent into moles. So we're gonna start with 40 grams of C2H6O2, and we're gonna use the molar mass for the ethylene glycol, which is 62.07 G's. Sorry. All right, and then we're gonna put it over 1 mole, and the grams cancel out. All right, and we can solve for that. That's going to be 40 divided by 62.07. All right, and I get 0.64. I'm gonna put 0.64. Let me double check that's right. So yeah, 62, 40 grams of that. Okay, so 40 divided by 62.07, 0.64. All right. Okay, now we're gonna do the same with the grams of the solvent, which in this case is water because it's an aqueous solution. So we're gonna do 60 grams of H2O, and since the molar mass of H2O is 18 grams over 1 mole, we're left with let's see, 60 divided by 18. I'm left with 3.3 repeating, so I'm gonna put 3.3. Yeah, 3.3. 3. All right. Okay, so now we can solve for the mole fraction. All right. For the mole fraction of ethylene glycol. All right, so you just plug in the numbers that you got, which is these. You plug in the moles of both of the solutions, not the solutions, the little compounds over here, into the what's it called? To the mole fraction. Okay, so you're gonna put ethylene glycol on top, which is 0.64. And you're gonna put H2O on bottom, which is 3.33. Then you're gonna multiply that. Wait a second, mole fraction. Okay, you're gonna add the ethylene glycol moles, so 0.64. Okay, so once you do that, you just solve for that, and you should get your mole fraction. So you should get 0.64. Actually, let me do this first because I want to make sure this is correct. So it's 3.33 plus 0.64. Okay, so I get, this is 3.97. Okay, and then 0.64 divided by 3.97, and I get 0.16, and that's gonna be your mole fraction. And that's the question. The question asked for molality, molarity, and mole fraction. You got the molarity, 6.77. You got the molality, 10.7. And you got the mole fraction, 0.16. And that's it for that question. All right, for the next question, this is question 63. All right, so pentane and hexane form an ideal solution at 25 Celsius. The vapor pressure of pentane and hexane are 511 and 150 torr, respectively. A solution is prepared by mixing 25 milliliter pentane with a density of 0.63 grams over milliliters with 45 milliliter hexane with a density of 0.66 grams over milliliters. So this is a two-part question. Part A is asking for the vapor pressure of the resulting solution, and part B is asking for the composition by mole fraction of pentane in the vapor that is in equilibrium with the solution. I went ahead and wrote the molar masses for, what is that, C5H12, that is pentane and hexane. This is pentane, this is hexane. All right, so let's get started. So in order to solve for the vapor pressure, we first need to convert the milliliters into moles. Okay, so we're gonna start that by starting with the 25 milliliters of pentane. Okay, so now we're going to multiply that by the density that was given, which is 0.63 grams over mole or milliliters. So 0.63 grams over milliliters. And we're going to multiply that by 1 mole and the molar mass of pentane, which is, what pentane is, C5. Okay, that will be pentane right there. So 72.15. 72.15. All right. And then, since that's that, milliliters will cancel out right here and right here. Okay, and then don't forget right here, this is grams too, I forgot. And then these will cancel out as well. So now let's see what we get for that. All right, we get 25 times 0.63. We get 15.75 divided by 72.15. And I get 0.21829, so I'm gonna put 0.22. All right. So now we're gonna do the same for hexane. This hexane we got, okay, for hexane we got 45 over here. All right, so let's do this. 45 milliliters of hex. I'm just gonna put hex, and then times the density, which is 0.66 right there. I'm sorry, it's because I'm holding this with my hand. All right, so 0.66 grams over milliliters. All right, and then we're going to multiply that by the molar mass again, which is 1 mole. The molar mass of hexane is 86.17. 86.17. And let's see what we get. Okay, so we got 45 times 0.66. I got 29.7 divided by 86.17. And I ended up getting 0.34 for 667.518. So I'm just gonna put 0.34. All right. So now that we got that, we can find the total mole, because it's gonna ask for the resulting solution, which is the total of everything. So that's gonna be we're gonna add these two up together. So we can do 0.22 plus 0.34. Let's see what we get. 0.22 plus 0.34. All right, and we end up getting 0.56. Okay, so we got 0.56. All right, and now with that, we're gonna divide the moles of pentane by the total moles, which was 0.56. All right, so now we're gonna do 0.22 divided by 0.56, and that gives us, and this is moles, 0.22 divided by 0.56, and that gives us 0.39. All right, and now we can get 1 minus the other one, which is hexane, 0.34, and we get 1 minus 34, or 0.34, 0.66. All right, and now with those numbers, we can start the next process, which is going to be finding the vapor pressure. All right, so in order to do that, we're going to have to multiply both of these numbers that we got. We're going to multiply them by the vapor pressures that we're given, which is up here is 511 and 150. So let's start with what's it called? Pentane. Right? Yeah, pentane. All right. So for pentane, we're going to do 0.22 39 times the 511 over here. 511 times 511, and we get 0.36, 39 times 511, and we get 199.29. All right. And then for the next one, we're gonna do 0.66 times the, we're gonna do 0.66 times the other vapor pressure, which is 150, and we get 0.66 times 150, we get 99. All right, 99, and you can put torr. All right, and now that we have this, we just have to add both of those vapor pressures up. So we got, oops, let it focus. We got 199.29 plus 99. Sorry, 199.29 plus 99. And I'm giving 298.29 torr. So it's 298.99. No, wait. Oh, it's because I was writing torr. 298.29 torr. And that would be the vapor pressure of the resulting solution. So we can go ahead and box that little answer right there. All right, so now that we got that, we can move on to section 2, which is this little question: what is the composition by mole fraction of pentane in the vapor that is in equilibrium with this solution? Okay, so this is really easy now, because since we already calculated both of the vapor pressures over here, this should make our life a ton easier. Okay, so since it's asking for the mole fraction of pentane, all we have to do is use the vapor pressure we got for pentane, which in our case would be 199.29, and divide that by the total pressure of the whole solution, which was this number right here, 298.29, and you can put torr. All right, and then we solve for that. So this would be 199.29 divided by 298.29, and we get 0.67, and that would be the mole fraction. We can put a little box. All right, and that's it for those two little sections, or those two little questions right here that were there. And we found vapor pressure and the mole fraction. All right. Oh, focus. Okay, so this is question 67. Which of the following will have the lowest total vapor pressure at 25 degrees Celsius? We got 4 choices: pure water, with a vapor pressure of 23 torr at 25 degrees Celsius, a solution of glucose in water with XC6H12O6 equals 0.01, a solution of sodium chloride in water with XNaCl equals 0.01, a solution of methanol in water with XCH3OH equals 0.2. Consider the vapor pressure of both methanol of 1.43 torr at 25 degrees Celsius and water. So right off the back, we can tell that the pure water and the pure methanol are going to have the highest vapor pressure of the four options that we currently have. And since methanol is more volatile than water, you can tell by the numbers. Methanol is going to be the one with the highest pressure, and following it will be pure water. So we're left with a solution of glucose in water and a solution of sodium chloride. And since glucose is a non-electrolyte, and since there will be more solid particles in the water with sodium chloride, we can easily cross out B, A, and D, and thus leaving us with, and this will leave us with C as our answer. The solution of sodium chloride in water with XNaCl equals 0.01. Alright, so this is the last question. An aqueous solution of 10 grams of catalase on enzyme found in the liver has a volume of 1 liter at 27 degrees Celsius. The solution's osmotic pressure at 27 degrees Celsius is found to be 0.745 torr. Calculate the molar mass of catalase. Alright, so we're gonna need the molarity for this question. So we're gonna use the osmotic pressure equation to solve for this. So we're gonna use this, and we're gonna do osmotic pressure, something like this, over ideal gas constant times the temperature. Okay, and that's gonna be the equation we're gonna be using. So we are giving the pressure right here, so that's, we're gonna use that right now, 0.745 torr times 1 atm atmospheric pressure over 760 torr. All right. And so at the bottom, the ideal gas constant that we're going to use is going to be 0.08206. All right, and then over K mole. And then we're going to multiply that by the temperature, which our temperature happens to be 27 degrees Celsius, but we need it in Kelvin. So in order to do that, we're going to do 273 plus 27, that's 10, 27, that's 10. We end up with 300 Kelvin. All right, and now that we have our numbers, we're going to solve for this using our calculator. All right. So we put in 0.745 torr, and then we can divide that by 760 divided by 760, and we get this big old number, small number actually. And then we're going to divide it by this right here. So divide by 0.08206 times 300. Okay, and then I put that in parentheses, so that's what we get. So 300 times that gives us that, and then we just click enter again, and then it should divide this by that, and we get, all right, we got this small number, which is 1, 2, 3, 4, 5. Okay, so 3.98 times 10 to the negative 5. Yep. And then after that, we're gonna start, we're gonna need, now that wait a second. Wait, okay, yeah. So we put our mole over liter. All right. So you see, we still have liters here. We want to cancel that out. We're giving liters somewhere here in the problem right there. It's right there. All right. So we're gonna do 1 liter, and then we're gonna multiply that times the number we got, 3.98 times 10 to the negative 5 mole over liter. Technically, yeah, that works too. And that basically cancels out liters right there. And you're left with just 3.98 times 10 to the negative 5 mole. And now that you have moles, you can find molar mass. Because you're also given grams here. It says an aqueous solution of 10 grams. All right, we got 10 grams up there. We got moles. So in order to find molar mass, you're gonna do grams, just 10 grams over the moles that we got, which is this number right here. So 3.98 times 10 to negative 5 mole. And then we can find the answer with our calculator. We got 10 divided by 3.98 e to the negative 5. 3.98 e to the negative 5. And we are given that number right there. So we're going to put it in scientific notation. It's going to be 2. It's going to be 2.51 times 10 to the 5 grams. 2.51 times 10 to the 5 grams over mole. And that is our answer. That's our molar mass. And that's it for the problem right there. We found a molar mass. That's what it was asked.